Hello everyone. Let's look at question 18 where we are given the x component and the y component of a vector, and we are asked to find the magnitude and the direction of the vector that will break down into those two components. So we are given the components here and we need to find the magnitude and the direction of the vector. Now to do that, we know that this actually complete a right angle triangle if we move the y component from this position to this position while maintaining the direction and the magnitude. Recall that you can move vectors from one position to another as long as you are keeping the same direction and the same magnitude. So this is v sub y. And the sum of two vectors will be the vector that connects the tail of the first one to the tip of the second one. So this will be the sum of the two vectors vx and vy. This will be the resultant vector. We'll call it v. And this is the related angle. We can call it theta sub r. And of course, the standard angle will be the angle from the positive x-axis counterclockwise to the vector. So it will be 180 plus the related angle. That's the standard angle. Now you can see here that v, which we need to find its magnitude and direction, is the hypotenuse of this right angle triangle. Of course, this is the right angle here. This is the 90 degrees. The vy, which is the y component of the vector, is the opposite to the angle, the related angle, and v sub x is the adjacent. Now, since we don't have the angle, we cannot use any of the trigonometric function to find v. So we have to use the Pythagorean theorem. Since v, the resultant vector, is the hypotenuse, its square is equal to the square of the adjacent plus the square of the opposite. So we can set it now that the magnitude of v, and we represent the magnitude by absolute value, is equal to the square root of vx squared plus vy squared. And this will be equal to the square root of vx, which is negative 28. And of course, when you square it, the negative will disappear because negative times negative will give you positive, plus the square of the y component, which is a negative 36 meter per second. And this is squared. And I'll let you do the calculation here. So make sure you square the 28 first, then square the 36, then add them. And then after that, you'll take the square root. So I'll let you do the calculation here for the magnitude of v. Now let's go to the direction. And this is important here. I have chosen number 18 instead of number 17 because it's not in the first quadrant. It's in the third quadrant. So when we find the angle, it will not give us the standard angle. It will give us the related angle. Since tangent the angle is equal to the opposite, which is v sub y over the hypotenuse, v sub x. Hence, the angle itself, and here we are talking about the related angle, this angle here, because the opposite is with respect to the related angle, the hypotenuse is also with respect to the related angle, the adjacent is with respect to this related angle. So we are talking about the related angle here, is equal to the tangent inverse. We have to take the tangent inverse of both sides. Tangent inverse of tangent will leave you with the angle. Tangent inverse on the right hand side will be tangent inverse of v sub y over v sub x. We'll plug the values. Tangent inverse of v sub y, which is 36, and you don't need to include the signs here because we know we are going to add 180 anyway, so you don't have to worry about including the signs. There is nothing wrong, you can include the signs, but it will not make a difference here. So go ahead and go with 36 for the y, this component here, which is equal to this component, 36, over v sub x, which is 28. So it's tangent inverse of 36 over 28. Make sure your calculator is set at the degree mode, not the radians. And if you do the calculation, this will give you the related angle, which should come out to be 52.13 degrees. This value represents this angle here, the related angle. Now to write the vector v in the form of magnitude and direction, it has to be in this format. It has to be the magnitude and then the symbol at and then the direction, which represents the angle, the standard angle. You can say here 52.13 third quadrant. That's one way to write it, at 52.13 degrees third quadrant. Or better is to write it in the term of the standard angle, and usually I will ask you to write in terms of the standard angle. So you have to add 180 to the 52.13 degrees. Remember, in the third quadrant, to find the standard angle, you have to add 180 because from this point to this point here, this angle here is 180 plus the related angle, which is 52.3. And of course, the magnitude is this value here that you found using the Pythagorean theorem. So you write the magnitude and the direction. So now if we write the answer here, I'm going to scroll down and write the answer here in terms of the standard angle. So V will be whatever the magnitude you calculated using the Pythagorean theorem here. And now you'll add 52.13 to 180, and this should give you 232.13 degrees. Okay, this is the right way to express a vector quantity by a magnitude, which is the value of the vector, and direction. You have to include the direction. This has to be the standard angle, not the related angle. So question number 17 is the same thing, but it's easier since it's in the first quadrant. So the related angle is equal to the standard angle. All right, I hope you found this video educational. Thank you.